So in this video I am going to expose you to the idea of fundamental theorem of arithmetic. So first let us write its statement. Fundamental theorem of arithmetic. The statement is, it states that every composite number can be expressed as a product of primes, where the factors are unique apart from the order in which they appear. Tells that if we have any composite number, then we must be able to express that composite number as the product of primes. And I think you must be familiar with a composite number. So let me remind you what is a composite number. A composite number is a number which has more than two factors. So let me make you understand with the help of few examples. So let us pick some composite number. Let's say 6. So 6 is a composite number. It has more than two factors. So as per fundamental theorem of arithmetic, 6 can be written as product of 2 times 3, which is prime number. So here we have expressed 6, which is a composite number, as a product of prime numbers. Okay, so the first part is done, and the second part tells us that the factors are unique, which means that to build up 6, the only factor which is responsible are 2 and 3. Apart from 2 and 3, there is no more prime numbers which can make 6. Okay, let's say we have another composite number 18. So build up 18. So 18 is 2 times 9, and since 9 is a composite number, so 9 can be break down into 3 times 3. 2, 3 and 3 are composite prime numbers. So 18 can be written as 2 times 3 times 3. So here 2 times 3 times 3 are the only factor which can make 18. So we have successfully proved the uniqueness part of this theorem. And the last part tells us that the order doesn't matter, which means that 2 times 3 can also be written as 3 times 2. Okay, we can change the order, which will not impact the answer. Okay, the order in this situation doesn't matter. Multiplication is commutative. The order can be swapped. Same case, 2 times 3 can be written as 3 times 2 times 3. Any order. In any order we can write this factor, which will not affect the answer. Okay, so now let me show you some application of this technique. So first we will start with the basic one. We will find the Hcf and Lcm by using this technique. Hcf and Lcm of, let's say the number 26 and 91. So here we will find the Hcf and Lcm of 26 and 91 by using fundamental theorem of arithmetic. Okay, so 26. So we will write 26 as the product of primes. So let us find the factors in rough. So 26. So the first prime which divides 26 is 2, and 2 goes into 26 13 times. Okay, so we are done, because since 13 is also a prime number, so it cannot be deduced further. So 26 can be written as 2 times 30. Okay, now 91. Okay, so 91. So let us find the factor of 91, the prime factors of 91. So 91, 2 does not divide 91, 3 does not divide 91, 5 cannot divide 91, 7 divides 91. So 7 times 1 is 7. Okay, to carry 21 3 times. So 91 can be written as 7 times 13, since 13 is a prime number. 7 times 13. So in order to find the HCF, we take the common factor of these two numbers. So here the common factors is 13. So here the HCF is 13, and the LCM. So in order to find the LCM, we take the common one and also the uncommon one. So 13 is the common one, 2 is uncommon, and 7, which is equals to 13 times 2 is 26, and 26 times 13 times 2 is 26 times 7 is equals to 7 times 6 is 42. 4 carry, 7 times 2 is 14, plus 4 is 18. So this sum up to 182. So here HCF is 13 and the LCM is 182. So we have successfully find the HCF and LCM of these two numbers by using fundamental theorem of arithmetic. Also there is one more relation. The relation is there is relation between HCF and LCM. It tells us that the product of number tells us that the product of number equals HCF times LCM. HCF times LCM. So let us prove this relation. So the product of these two number, which is 26 times 91, which is equals to, let us multiply 26 times 91. Okay, I will do this in rough. 91 times 26. Let us multiply. 6 times 1 is 6, 6 times 9 is 54. This is 0, 2 times 1 is 2, 2 times 9 is 18. So 6, 5 plus 8 is 13, 1 carry 2. Okay, so the product of these two numbers is 2366. Okay, so now we will do the right hand side part, which is we will multiply HCF and LCM. So here HCF was 13, LCM was 182. So let us multiply 182 with 13. So let us check 182 times 13. 182 times 13. So 3 times 2 is 6. 3 times 8 is 24. 2 is carry. 3 times 1 is 3. 2 carry 5. We leave this space. 1 times 2 is 2. 1 times 8 is 8. 1 times 1 is 8. 6. 4 plus 2 is 6. 5 plus 8 is 13. 1 carry 2, which is also 2366. So the product of the HCF and LCM is same as the product of these two numbers. So we have successfully verified this relation. So this relation is true for every two composite number. Okay.